The importance of conserving water cannot be understated. Water is a finite resource, and as our population grows, the more valuable water will become. It is important for us to conserve water now so that our planet may continue to thrive. Currently, UBC Okanagan residences use 20.1 million liters of water a month, and with UBCO's planned expansion, this number will only increase. As students, we are invested in our school's accountability in being sustainable, and our team has been tasked to find a solution that benefits the university and the environment.
Our group determined that the best solution was a combination of a purple pipe system paired with leak detection due to the independence of user interaction as well as the cost-benefit analysis of the system. When deciding on our final solution, we took into account cost and length of the project, the campus image, ecological footprint, repairability, and water saved.
For our proposed solution, we had 3 levels of testing that we had to go through. The first of which was a footprint test done in SolidWorks of our proposed solution for the water treatment plant. This involved laying out the piping and the water treatment system that would be included in new residence buildings. By doing this, we determined that our proposed solution would be feasible in the new campus infrastructure plan. From here, we could continue our testing with lab work to determine the water treatment process. This lab work was mainly to determine how much treatment our plant would have to go through before the water would be usable again. These tests told us that our gray water would be easy to treat and redistribute into the system. Our final test was testing of the moisture sensors. For this, we bought moisture sensors that would be compatible with an Arduino board and wrote a quick program that would determine the difference between a control sensor and a measuring sensor. The control and moisture sensors together will measure the difference in moisture and set off an alarm when a large difference in moisture is read. All 3 of these tests together told us that our proposed solution would not only be relatively easy to implement, but successful in the future campus infrastructure plan.
We calculated the cost of our project on a per building basis. The factors that we included into our cost benefit analysis include machinery to complete the project, materials such as piping sleeves and water treatment filters, waste disposal, and salvage value. Our total cost for our 10-year plan was calculated to around $12,500. Our 5-year plan was around $9,300. Our solution would yield a net profit of $66,000 for a 5-year plan, and again, these values were per building. In total, our purple pipe solution would save UBCO around 28,040,000 liters of water per year.
We plan to implement a leak detection system as well as new water treatment systems in residence buildings on campus to alert maintenance staff of a potential loss of water and flooding damage. Moisture sensors will be placed on every pipe with 1 meter of spacing between them. Each sensor on the pipe will be paired with another sensor which will act as a control and compare the moisture on the pipe to the moisture in the surrounding area, determining if the pipe is allowing water to flow out or if the air is just moist at that time. This moisture detection system will provide real-time data on water loss around campus and provide information on where the leak is located within a 1 meter radius. This system will effectively reduce water loss and damage because the water can be shut off as soon as a leak is detected and can be quickly and efficiently repaired without the need for an exhaustive search while finding the leak.
We plan to implement a water treatment system in new buildings that will take water from showers and sinks to be filtered. Our water treatment system will treat the water for use in 2 classes. The first stream of water will be able to be used for toilet water in residences. The second will be used for agricultural and irrigation uses. We did not think it necessary to implement a water treatment process that could produce clean water that is to drinking standards, as this would be much more costly, and our process should still be able to keep up with the supply of wastewater. The main portion of the process would be the disinfection of the water, as organic matter tends to produce harmful bacteria in the water. Disinfection is also important to reduce chemical oxygen demand levels for the wastewater as well. The system would also manage the pH, turbidity, as well as salts dissolved in solution using membranes, as well as reverse osmosis.
Our group went ahead with the proposed purple pipe and leak detection system since it was a good mixture of an economically feasible plan mixed with good water conservation. Our profit of $60,000 per building can be a motivator for UBCO to continue to grow the campus. The water conserved by a project also completes the university's goals of reducing water consumption and creating a more sustainable campus.